Many people believe that airplane toilet waste is dumped into the air the moment the flush button is pressed. While this idea might seem logical given the staggering altitude, it is entirely incorrect. If this were actually to happen, the areas and homes beneath flight paths would suffer catastrophic damage, and it would violate the most fundamental environmental and safety regulations. The reality is that what you see is not merely an opening to the outside, but a complex, high-tech engineering system. Have you ever wondered how passengers relieved themselves in the early days before these systems were invented? What is the story behind the terrifying blue ice that actually used to fall from the sky onto people's homes? More importantly, what is the physical secret behind that frightening suction sound despite the scarcity of water? In this video, we will reveal the amazing behind-the-scenes details of one of the smartest engineering systems in the world. But before we dive in, if you're new to the channel, make sure to hit the like button and subscribe. In the early days of aviation, luxury was non-existent. Planes were small, flights were short, and toilets didn't exist at all, so passengers simply had to wait until landing. However, as distances and passenger numbers increased, this became impossible. The first primitive solutions appeared in the form of buckets, which was, of course, a terrible and unsafe experience, especially during turbulence. As the aviation industry grew, the first real system emerged, the gravity toilet. Its concept was very simple: a hole in the aircraft floor connected to a valve. Once the lever was pulled, gravity and the external airflow took over to pull the waste and dump it directly into the atmosphere. Engineers preferred the gravity system because it was lightweight and rarely malfunctioned, and passengers liked it for the air's ability to quickly expel odors. But it wasn't perfect, as waste sometimes wouldn't be completely cleared. Later, water was used for flushing, but this solution faced the obstacle of weight, as every extra liter of water increased fuel consumption and flight costs. A capacity problem also emerged. If the tanks filled up midway through a long flight over the ocean, the toilet would stop working entirely, leaving passengers in an unenviable position. One of the strangest problems pilots faced during that stage was the emergence of what became known as blue ice. In an attempt to eliminate odors, airplanes used a blue chemical disinfecting liquid. However, due to design flaws, minor leaks occurred. Because of the extreme cold in the atmosphere, reaching 50 degrees below zero, this liquid would mix with waste and freeze instantly on the aircraft's fuselage, forming blocks of blue ice. The disaster would occur during descent, when these blocks detached and fell from the sky. Real cases were recorded where this blue ice fell on houses and cars. These dangerous incidents were the straw that broke the camel's back, proving to engineers that the toilet system required a revolution and a radical change, rather than just simple improvements. In the 1980s, a Boeing engineer sparked a true revolution with a simple question: why don't we use air instead of water? This led to the birth of the vacuum toilet system used in all modern aircraft today. Although the toilet looks ordinary from the inside, its inner workings are fascinating. It consumes only a tiny amount of water, about half a cup, just to moisten the surface. Since the bowl is coated with an ultra-smooth, non-stick material, this small amount of water combined with the power of air suction is more than enough to get the job done with total cleanliness. This brings us to the real secret. Beneath the toilet lies a smart valve that separates the passengers from the waste system. The moment the button is pressed, this valve snaps open, creating a massive air vacuum that pulls everything inside with an incredible force, far stronger than any vacuum cleaner you've ever used. That loud, sudden sound that startles many is not the sound of rushing water, but rather an air blast caused by air moving at extreme speeds due to the pressure differential. Once this 1-second process is complete, the valve seals shut tightly again, and the waste settles inside a completely isolated compartment known as the waste tank. But where does this immense suction power come from? The secret lies in the clever utilization of the laws of physics. While airplanes on the ground require an electric pump to generate suction, they get it for free while in the air. At high altitudes, the air pressure outside the plane is very low, while the air inside the cabin is kept at a high, controlled pressure. As soon as you press the button, the system opens a small gap, causing the air to rush from the high-pressure interior toward the low-pressure exterior, dragging everything in its path with immense force. The result of this engineering brilliance is a highly intelligent system that is lightweight, water-efficient, and works in perfect harmony with flight conditions. To settle the debate once and for all, airplanes never dump their waste into the air. Everything is locked inside a sophisticated, heated, and vibration-protected tank, and the emptying process only takes place after landing. An external service vehicle suctions the waste and cleans the system. And the surprise is that there is no button or means that enables the pilot or crew to empty the tanks while in the air. All valves are external and can only be opened manually from the ground, which makes stories about dumping waste over oceans merely myths with no basis in reality. Interestingly, ships and airplanes treat the same problem in completely opposite ways. On cargo ships, the matter is simple. Weight is not an issue, the environment is stable, and they use simple biological treatment systems. An airplane, however, operates in an impossible environment where every extra kilogram costs fuel, pressure changes suddenly, and the cold outside freezes everything. Therefore, engineers had to abandon simplicity and focus on maximum efficiency. In short, the ship bets on durability, while the airplane bets on precision and intelligence. Many people ask a concerning question: is the water on an airplane safe to drink? The short answer is yes. The water loaded onto the plane is regular drinking water subject to strict monitoring. Nevertheless, there is a smart piece of advice. Pilots always prefer drinking bottled water. As for tea and coffee, there is no need to worry, as boiling the water during preparation kills most bacteria and makes it safe for consumption. The evolutionary journey of airplane toilets is a story of incredible engineering success. Honestly, who among you still presses the flush button and runs quickly out of the bathroom or covers their ears before hearing that terrifying sound? Let me know in the comments. We have now reached the end of the video. Thank you for watching.